Hi guys, so in this video we're going to be looking at another part of trigonometry to do with circles and triangles and all of that. So we're kind of combining everything we've learned while also putting in radians. So this is kind of related to trigonometry, except it's also leaning a bit more towards radians. So it's a little bit of a gray area in that sense. But so I'm just going to go through a couple of practice questions, and using the radians knowledge and trigonometry knowledge we've accumulated, we can try and solve them. So if you want to do it yourself, then pause the video before I attempt each question. All right, so the shaded region in the diagram is a segment of a circle with center O and radius r cm. Angle AOB is pi over 3 radians. So the first part of this question is show that the perimeter of the segment is r times 3 plus pi over 3 cm. All right, so they're talking about the segment over here, the shaded part over here. So what I'm going to do is I'm going to label each of these components, and then we're going to find them out separately because we can't find them out together. All right, so let's say AB is denoted by the letter A, and then this arc over here, wait, let me just draw that roughly. That arc is going to be B. So let's start with finding A. So A is, well, what we can do for A is, since we have an angle in the center of two sides that we know, we can use the cosine rule. So A squared, rather, is equal to the first side length squared plus the second side length squared minus 2 times the side lengths times the cosine of the angle, which is pi over 3. So that means that A squared is equal to 2r squared minus 2r squared, and then cos of pi over 3 is the same as cos of 60, and as we know, cos of 60 is half. So that gives us A squared is equal to 2r squared minus, and then this cancels out, so minus r squared. So A squared is equal to r squared. So that means that A is equal to plus minus r. Of course, though, we're looking at an actual side length, so that cannot be negative. So A is equal to r. So that's the first part. Now we need to find B to get the perimeter, because the perimeter is A plus B. So to find B, we just need to realize that according to our radian rules, B is equal to theta r, where theta is the angle. So that means that B is equal to theta, which is pi over 3 times r. So it's pi over 3r. So now we just add these up. So P is equal to A plus B, which is equal to r plus pi over 3r. So we can factor out an r. So we get r times 1 plus pi over 3, which is the same as r times 3 plus pi over 3, since 1 is the same as 3 over 3. And that's exactly what we were looking for. So part 1 is done. Now we're going to go to part 2. So given that the perimeter of the segment is 26 centimeters, find the value of r and the area of the segment. So we can just say, so we've already got an equation for the perimeter. So r times 3 plus pi over 3 is equal to 26, which is the given perimeter here. And let's just solve for r. So multiply everything by 3 is the first step. So r times 3 plus pi is equal to 78. So r is equal to 78 over 3 plus pi. We're not going to simplify it yet because we do want to make it as exact as possible. So let's use the exact value of r. Now, what the question wants us to do is find the area of this segment. So the way we can do that is, well, there's not a specific way of finding this area, but there is a way of finding the area of this whole triangle and the whole sector. So if we do the entire sector minus the area of just the triangle, we'll get the remaining part, which is the shaded part over here. So let's say A is equal to A of let's call it segment, is equal to A of sector minus A of triangle. So A of sector is equal to, well, what we can say is that the area of the sector is equal to half theta r squared, as the formula given, as said by the formula given in the last video that we covered, that we deduced. So that's equal to half times the angle, which is pi over 3, times the radius, which is 78 over 3 plus pi. Although I think it's best if we substitute the radius in later. So let's just put it as r squared, which is equal to pi over 6r squared. Now the area of the triangle is equal to, so we just need two side lengths and an angle. It's half AB sine C. So that means it's equal to half times A times B times sine of pi over 3, which is the same as sine of 60, which is sine of 60 is equal to root 3 over 2. So that means that this is root 3 over 4r squared. So that means the area of the segment is equal to pi over 6r squared minus root 3 over 4r squared, which is equal to r squared times pi over 6 minus root 3 over 4. And we have to simplify that down. So what we know is that r is 78 over 3 plus pi. 78 over 3 plus pi, we're going to square that, times, and then we can make this one fraction, so 4 pi minus 6 root 3 over 24. So 78 over 3 plus pi all squared. Well, we know 78 squared is equal to 6,084. And then 3 plus pi squared is 9 plus pi squared plus 6 pi. And that's multiplied by 4 pi minus 6 root 3 over 24. Now, since this is too complicated to try and simplify, what we can just do is put it into our calculator. So we get 6,084 divided by 9 plus pi squared plus 6 pi. And we multiply that by the other fraction we've given. So 4 pi minus 6 root 3 over 24. Which gives us the answer 14.61. And we're going to call this cm squared because the units they gave for the perimeter were in cm. So it's 14.61 centimeters squared in terms of the area. So that's how we kind of do those kind of problems. Remember, if there's not a formula for it, there's typically a way of calculating other things that will eventually, like, when you establish the relationship, we'll be able to find things that you can't use a formula for. So in this case, we use the formula of a sector and a triangle to get the other formula. So just try and keep these relationships in mind. Let's move on to the next question. All right, here's another question that we're going to do. It's going to be our last one, but hopefully after this we'll have a pretty good idea of how to approach these kind of problems. So the diagram shows a circle, center O, radius 10 cm. The points A, B, C, and D lie on the circumference of the circle such that AB is parallel to DC. The length of the minor arc AB is 14.8 cm. The area of the minor sector ODC is 21.8 cm squared. So write down in radians angle AOB. So when they say write down, it typically means that this is something that can be solved just by basically doing one calculation or looking at the picture sometimes even. So in this case, it's not immediately obvious, which is why it may be deceptive, but the 1 mark tells us there's a very quick way of doing it. So this is the angle they want us to find. It's called theta. So as we know, we have the arc length and we have the radius. We know that the arc length is equal to theta r. So obviously you need the angle for that. So arc length is equal to theta r. And we can just substitute and solve for theta. So we know that 10 theta is equal to 14.8. So theta is equal to 14.8 over 10, which is equal to 1.48 radians. The sign for radians is actually a small c at the top like this, but I'm just going to write radians like this because you might not be used to the notation. So find in radians angle DOC. So DOC is this angle over here, just like that. So we're asked to find what angle DOC is. So this is 2 markers, so it's going to require a little bit more effort. It says that the radius is 10 centimeters of this circle, so we can just label these 10. And it says that the length of the, the area of the minor sector ODC, which is this portion over here, is equal to 21.8 cm squared. So we can actually use that to help us. So we know the area of a sector is 21.8 cm squared, or it's equal to half theta r squared. Area of sector ODC, let me mention that. So what we can do is we can substitute what we know. We know the radius. We can find the angle by then solving for theta. So half theta r squared is equal to 21.8. So theta r squared is equal to 43.6. So 100 theta is equal to 43.6. So theta is equal to 43.6 over 100, which is equal to 0.436 or 0.44 radians. So as I mentioned earlier, you can just use some of these relationships to solve for these things. All right, so now let's find the perimeter of the shaded region. So if we go back here, we've already got the arc length of 14.8, but we need to get the length of AD and BC. So length of AD and BC are the same since these two parts are parallel. So we can call these by the same variable. Let's call this A. Now, the other thing we need to figure out is this part over here, the arc of DC. So we're going to call that B. So the first thing we can do is we can try and solve for A. So what we know is that this angle over here is 0.44. Let me just erase this. So we know that this is 0.44 and this is 1.48. Since we know this is a circle, the angle has to add up to 2 pi. So 2 pi minus 1.48 minus 0.44 means we have not accounted for 4.36 approximately. So 4.36 radians are between these two angles over here, and we know that they're equal. So therefore, if we divide it by 2, we know that each of them are 2.18 radians in measurement. So now we can find the length of A. All we have to use is cosine rule. We've got length, side lengths, and an angle in between them. So let's do that right now. So A squared is equal to, and then our side lengths are 10 and 10. So 10 squared plus 10 squared minus 2 times 10 times 10 times the cosine of the angle, which is 2.18. 2.18 radians, it's important to mention. Oops. Don't know why that keeps happening. That's equal to, so 10 squared is 100, so that's 10 squared plus 10 squared is 200 minus 200, and the cosine of 2.1, it's 2.18, I think. Yeah, it's 2.18. So I'm just going to put that into my calculator. Make sure it's in radians when using it. Cos of 2.18 is negative 0.572 approximately, which is equal to 200 plus, and then we multiply that by 200 plus 114.4, which is equal to 314.4 approximately. So that means that A is the square root of 314.4, which is equal to, just put that in my calculator, that's equal to 7.73, let's say for now, because I'm just truncating it a bit now. 17.73. So what we need to do now is find the length of B. So B can be found by multiplying the radius by the arc, but by the angle, so that's 10 times 0.44. So B is equal to 10 times 0.44, which is equal to, just putting in my calculator, that's equal to 4.4. So now we have everything we need to find the perimeter. We just add them all up. So we add up 14.8, the top part here, plus 2 times A, so 14.8 24.8 plus 2 of A, which is 17.73, plus 4.4, which is equal to 14.8 plus then 17.73 times 2 is 35.46 plus 4.4. And all of that added up is equal to 54.66 centimeters. Or 54.7 cm. Whichever way you want to round it. So that's the perimeter. Now we need to find the area of the shaded region. So to do that, it's going to be a little bit trickier. But what we can do is divide it up into key sections again. So what I'm going to do is I'm going to highlight them different colors. So this over here is one portion. And this section over here is another, but it's the same as this, so we're gonna shade them the same color. And then our final portion is this bottom part over here, which we're gonna put blue. So this is how we're gonna distinguish what parts we're gonna be finding out. Because we can't find it together, like the area, but we can find them separately and then add them up. All right, so let's start with the yellow area. The yellow area it's a sector. So the sector is half theta r squared. That's the formula, and we have theta as 1.48, and the radius is 10. So it's equal to half times 1.48 times the radius, which is 10 squared. So that's equal to half times 1.48 times 100. And 100 times 1.4 is 148. So this is equal to 74 cm squared. And they've already given us ODC, so blue is already sorted. It's 21.8. So let me just... Now we need to find red. So red, we can use the triangle. We can use the formula of a triangle, which is half AB sine C, with A and B both being 10 and C being 2.18. So let me just write that down. So area, equals half times 10 times 10 times sine of, I think it's 2.18, yes. So that's equal to 50 times sine of 2.18, which is equal to 50 times, and then sine of 2.18 we can calculate 0.82, which is equal to 41 cm squared. And now we can just add them up. So we have 74, area is equal to 74 plus 21.8 plus, and then the red area is there twice, so 2 times 41, which is equal to 74 plus 21.8 plus 2 times 41, which is equal to 177.8 cm squared. And that's the area. So there you have it. You have to find different ways like these in order to calculate these complicated shapes. Just break it up into shapes that you know and that you have you can work with based on mathematical formulae. And there you have it. So thank you so much for watching this video. I hope that this gave you better understanding of how to approach these kind of problems, and see you in the next one.